and loops and loops. Okay, let's move forward, right? So let's analyze here what's going on to see where we are. So we can see that here in the right side, this is a return address, which basically means it's gonna return to the previous call. Sorry, it's gonna return after the previous call was made, and then that's it here. And then in the left side, we can see that it calls this delete mount point A. And if you don't know what is this API, guys, just Google it. You're gonna always check in Microsoft website, and it's exactly what I did. It's what I do always, right? When I don't know the API, so that you know what it's doing and what is the parameters being received. So that you know, this API, what it's gonna do is gonna remove a drive in your hard disk. So C, D, E, F, whatever it is the drive, which is the one that is being received here, is gonna be removed. Okay. After that, it's gonna come here, and if you can see, it's gonna do a check here. If it is jump 0, if it is 0, it's gonna jump over, and then from here, it's gonna just do some operations, and then come back in a loop. And then in this loop, again, comes back, and then goes into the same loop in the left side, do a remove, is not found, then it's gonna do the loop again. Or it can go into the right side and leave, okay? But as I told you guys, you don't need to know everything. You really want to move fast, but sometimes, like in this case, you really want to understand what's going on here, because you are trying to identify the next jump or the next path being executed by the malware, right? And we know that now we have the carnita, because we have these APIs, which doesn't look like part of the unpacking, because it's actually doing something malicious. It's trying to delete a mount point, which basically tells us this is carnita. So let's try to see what's trying to do to see where else is going. So here, I'm going to explain you quickly, guys, so that you know. So when it does the delete mount point, right, it's going to return a value, and check what is going to happen here. ECX, which is initialized with this value, is going to be moved here. EAX, which is exactly the same value that ECX was initialized, is moved here. Then it's going to do the subtract, and it should be 0, right, all the time. And then if it is 0, that means it goes over here. But when is the scenario that this should not be 0? When you guys call this guy, this API, and there is an error, what is going to happen is that ECX is going to be affected. And if ECX is affected, which means its value is going to be different, that means that this value different because there was an error. And why there is an error? There is an error because when you're trying to delete a drive that doesn't exist in the system, it's going to throw an error. Then if that drive doesn't exist, ECX is going to be altered, then that value is going to be sent to bar 84, and then when you do the subtraction, since ECX is now different, it's not going to be 0, and if it's not going to be 0, it's going to come here. Now, why do you think it's trying to do this validation? The reason is because the malware is trying to check if he already infected the system. If the drive that is trying to remove here, which by the way is RR, and we're gonna see it in the debugger in a second, the drive RR that is trying to remove, there might be created by the malware before. And then if it tries to remove it and it finds it, then there is no error. This guy, is not altered, and then I don't go here. But if the system, I don't go here, which means the system is already infected, because that drive RR that only me as a malware created it was found. But if that drive was not removed, that means it's not created, that means the system is clean, and then I get here. You get my point? Okay, so that's the whole logic. So then what is going on inside here? We can see that it do some operations and eventually do a jump X. This jump X is another dynamic call, guys. So what we are seeing here is that even though we unpack it, and we can see if we unpack it, because we can go to PE, try to open it up, this guy, and we can see that now it says Delphi. There is no more ASPack. So we were able to unpack it successfully, and we are actually seeing, these APIs, everything. But it's not enough, because still it's gonna try to do something else. What this means, guys, is that this is a multi-stage decoder. They started with the ASPack, and then probably this is part of the custom packer or custom obfuscator, whatever you want to call it, that the malware is using. So the strategy here, guys, is keep going in memory debugging and keep dumping. Whenever you feel that now it's fully loaded in memory, dump it. If you hesitate, dump it. It doesn't hurt, right? But obviously there are some pointers to know when you should dump it and when not. As I told you, when you see APIs like this, and you stop seeing just loops and loops and just XOR shift left shift right without any sense, when you see some more logic, it's when you want to really dump, fix the entry, fix the in parameters table, and see if you get multiple APIs, and then you are gonna understand that you might be in the right carnita finally. Okay. So because of that, now we understood this whole thing. So we're gonna put here after this delete mount, we're gonna put the breakpoint here, and actually I'm gonna double click. I'm gonna put the breakpoint here because it's where it is gonna be coming, or it's gonna be coming into this side. But I can put the breakpoint here. But I already, in my first try, I put the breakpoints in both sides, to see where it is hitting. And when you play, it hits here. So I realized this one is not being hit, right? But in the original effort, you always need to put breakpoints in the exits so that you don't miss any. Okay, F2 to remove the breakpoint, F7 to jump, and then here's another jump, and then here I do Control S, and we see that now we are, as we saw, executing in the text section, right? So here I do P, and it doesn't change to function. Anyways, we keep moving. Okay, I do F8 in case we get into a call to jump over it. And you can see, guys, that every single function has junk in between, or maybe it's not junk, maybe it's actually data that is being used to decode the next instructions. But anyways, this is enough for either to be confused. Okay, we keep going, and every time we keep going, see, it says, hey, you're jumping to a new section. I said, okay, convert it to code, treat it as code, and jump, and then I remove that warning. I always keep pressing P, guys, because that eventually is gonna treat it as function, and the only reason I wanna change it to function is so that we can see it in graphic view, and we can see the flow faster, because otherwise, like here, I don't wanna waste my time here. I don't see clearly the flow, and my methodology to going faster is not working here. I cannot apply it. I feel frustrated. Okay? But don't worry, guys. I'm going to be fine. Okay? Please. Don't worry. Okay, I keep going. I'm going to do P here. See, P, now it converts to function, even though it's not a function. I just going to see the flow. But see, it's a really small part because it's just after this is... See, after this, there is junk. So either it's like, okay, yeah, I can treat it as function, but it's like very, very small. Anyways, we do F7 here, we jump here, we go back again here, push, jumps, okay, push and jumps, and I do a P here, it doesn't do anything. So let's see, there's a call here, I do F8, I just want to jump over it. Then F7, jump. Let me do a P here. Okay, here again, convert it to function. I do space, and see, now looks like we have a more bigger chunk. Guys, so summary. Whenever you have this view, which is not being treated as function, every time you move, do P all the time so that you can see if in that execution address, finally either treated as function, so that then it can be represented in the graphic view. And then the reason being is you have flow. You can see this clearly than this. You don't even know where you are going here, guys, right? But here, you need to be in the place where there is a code so that you can change to graphic view. Because if you, for example, you are here and I do that, it says, hey, I cannot see that graphic in graphic view. It's important to be pointing to the place where is the instructions. So here, guys, we can see easily the flow. There is something here. We go here and see these guys, XOR EDI. So let's see what's going on there. So we jump here, then we get to the XOR. XOR, as you remember, guys, is just a decoding, people calling encryption algorithm. Anyways, in the left side, we have an address in square brackets. Basically means it is gonna store here the result of the XOR of whatever EDI is pointing with the key AL. Check where EDI is pointing to, guys. 4188F0. 4188E0 falls into this section, which basically means these guys are decoding right in text section with XOR, which is a good indicator that they might be jumping there suddenly. So we can see how it's doing it. So here I'm gonna in the memory view, I do G, and with G I do address 4188F0, right? So we get there. I'm gonna just highlight it here, and let's see what's going on here. So we do F7. You see that the first one was changed to 55. 55 is a push opcode in assembly. So we are seeing that they are converting this to code, which is great. And by the way, let me put just here a breakpoint. F2. Let me do it again. Play. You see, it changed the second to 8B, then the third to EC, and you see all of them. And AL is always 1C, so we can even decode this automatically. It's just 1 byte key. Okay. So now I'll do F2. I don't want to keep going. I'm gonna see what's going on. So in ECX is incremented, right? It's like a counter. Then EDI is incremented to the next place where it's gonna be decoded. Then it compares ECX with ECI. ECI, if you can see it, is C80. That is basically telling us that a total of 680 hexadecimal bytes are gonna be decoded here. Then after that, it jumps and it says, hey, jump below if ECX is less than ECI. As we can see, it's less. So we don't want to jump here because it's going to keep doing the same. You see, let's do it. We do this, we get into XOR again, then we come back, we increment, we compare again ECX with ECI, and keeps going. So I don't want to keep going here, so I go, if this jump is not taken, is when ECX is equal to ESI, which meaning is already done. So I put a breakpoint after this and do play. Okay, now you can see ECX is C80, same as RSI, and then I do F2 to remove the breakpoint here, and then F7, and see we are back into business. After that, there is more code here, so we do F7. I'm trying to do P, and it's not converting it, so we need to go here by this view. We go here. And here, guys, eventually we get into the jump EAX. Where is EAX pointing to? The 4188F0, which we just saw. And if you don't believe me that 55 is a push, let's see. 7, push. Okay? And 8B, by the way, is the EB. So that's why it's a push to EBP. This push EDI is a different. It's not AB, it's 8 something, I don't remember. Anyways, so now, guys, let's do P. We convert to function, we do a space, and we are back into the graphic view. Now, the question here is, we are here executing in text. We just saw that it just XOR decoded everything. The question is, are we in the carnita finally or not? Let's take a look at the code. We see that here is doing loops. We don't see any APIs be used. We see a call 5 that is just moving to the next. So we see here in the left side there is nothing. There is just code. We see a lot of loops. These loops telling us it's doing something. Here it has a call to something. Might be an API actually. And then after this there is a loop. Now here you can dump this right now and open it in IDA. I'm gonna save the time. I don't wanna waste it, obviously. I didn't know if this was already carnita, which means malicious code. So I dump it and I realized it's not. Then I came back again here. So I'm just trying to go faster with you guys. And another really good hint, guys, is that eventually when you are in the carnita, in the malware code, you won't see more jump EAX, jump those dynamic calls to something extra, because you don't need to jump to other places dynamically which were previously decoded, because you already decoded everything. So you just want to start executing your functions, right? That's another sign that whether you are still looking into the Packer obfuscated code or if you're finally into the meat. The meat is not going to decode anything else. It's just going to execute malicious actions. So if we go down here, guys, very fast, trying to find again exits, like a return or a dynamic call, we can see that the only one is this one. There is no more. You can check it, right? There is the only one. So I put a breakpoint here, and I'm going to do a play in order to reach there. Now, a very important point here, guys, that happens to me many times is that sometimes I put a breakpoint here, but you can see that I skip a lot of a lot of instructions, right? I skip a lot. If I do the play and I don't reach this guy, and suddenly the debugger stops executing because it exits, or suddenly I see that my machine shuts down or something indicating that the malware is executing now, that means that we never reached this point. What we need to do is we need to narrow it down. So instead of going here, you will need to probably put a breakpoint around here, for example, here, and then run it again and see if you reach this point. If you reach this point, great. Then you keep moving, and then you put another breakpoint here, and you know what? You know that? So if, for example, you put a breakpoint here and it doesn't hit, that means that probably you're not even reaching here. So it might be something probably in this loop, right? Eventually, you will find that there is a function that probably is calling a check if it is running in a virtual machine or something like that, that it detects that it is being debugged. There are multiple reasons, but the point here is that you start fast, going really fast as I'm doing, but if suddenly you don't reach the breakpoint, you need to narrow it down, going backwards, and quickly identify where is this program executing something that is now exiting. Probably this final jump EAX is actually the exit to the program, and probably there is something that here is the meat. Maybe here you're jumping to a heap address that it is the new meat that it is being executed. You get my point, right? It's always a trial and error, but the point here is don't waste your time doing reversing. Just focus on move fast, and if you don't reach that point, go backwards and try to find where gets stuck the malware. So I do play, and in this case I reach here, which is good. So then that means nothing else executed before, and then here you guys, we are seeing that it's now jumping into the heap 23A4. We do F7 and we are in the heap. We do P, change it to function, space to see the flow. I do Control S. We are seeing that now we are located in this heap area. IDA Pro creates new sections on the fly with the names when you have this heap allocation, and that's why we have debug 036. It's just a name that they put it. And here, guys, there is two options. One option is that this is the final meet where the whole obfuscation happens, move it into the heap, and then we jump here right now, and then this whole information here is the carnita, is the malicious actions. Or another case is that we jump here, and then from here, now the malware is going to decode the original binary in memory, it's going to decode this guy in memory and then jump back to this guy, okay? It's either way. But the main point here, guys, is if you have the doubt, dump it right now here, get your Zilla, dump it, and see what's going on. So actually, well, I don't want to waste your time because it's gonna take too long. But I dump it, and I still see a lot of loops. I didn't see APIs. And again, another hint that I told you before is when you look here, guys, you see these loops, you see these calls, you know, you keep going. We are looking for exits. We don't see exits here. We have code in the left side. It's moving, you know, it's moving here in the left side. Eventually it's just a loop, so there is nothing there. So we come back here. We have this second guy that comes here. Sorry, that was the same. So we come to this guy here. We go down. Eventually goes to the left. Sorry, to the right. Into the right we have now two paths. These two paths are, see, we don't have anything here. We have a loop, so we keep moving down. So we have a jump here but goes down. So we don't see a return, we don't see a dynamic call and without anything else, you know. When you see a dynamic call and nothing else, that means you reach a point where you don't know what's going on. So you can put a breakpoint there, is what we are looking for. So we don't see anything here. This, it keeps going, this loop comes back. So here this keep going down. See guys, it's a lot of information and a lot of commands, sorry, a lot of instructions that doesn't make sense. You don't want to be here. Move fast. I don't give a move fast. Okay, we reach here, guys. You know, we have this jump EAX again, and there is nothing else. Very important, there is nothing else. We just get to the bottom, and then there's a potential new jump. We put it there. We don't see anything else here. As you can see, there are just loops. Okay, so we just click play. We see that our breakpoint was hit, and we also see that IDA moves into this view. We are not in the graphical view, and if we do space, it says, hey, we cannot see in the graphical view. Probably because part of the code that was just decoded now messed up with the previous instructions. So I do F2 to remove the breakpoint, F7 to jump, and now see where we are, guys. 40, 98, 77. If you remember, we were here and now we jump back here. That tells us that definitely something new is here. And again, we are in the question of, is this the final entry point or not? We do P here, by the way, space, and see. We don't know if it is. Again, we are not sure. We don't see a call to a EAX. However, this can be the jump to the next decoder stuff, right? But we don't know. Let's dump it. As I told you guys, if you have doubts, just dump it. So at this point, we get this guy in memory. Okay, we get this potential original entry point. We put it here. We say search, say yes. We found the offset of the import address table. We said get imports, and check this beauty, guys. We got many APIs now listed, and we got this here, guys, which are 4069 APIs or potential APIs that were not identified. They didn't. The tool didn't identify any API in those addresses, which can be something that is a problem, and we really don't find those we don't find those APIs, or it's just because there is trash garbage in memory and the tool confused those pointers with with addresses of API table, import address table, and is trying to see if there is something else, right? I mean, can be multiple options, right? But at this point, we don't really are in the position to know that. So we're gonna dump it. Okay. We override the previous one, then we fix it with the dump that we just did. Okay, and then let's try to open it. So we open this guy, which by the way, I don't know what is this. Let me check 1 second. Let me check where we have here. We have AIDA here. What is this AIDA, by the way? Oh, this is the previous AIDA that we opened. You remember, guys? The one that we just saw at the beginning. Let me close it, because if we don't close it, since it is the same name, that's why I was seeing that IDB. And here, let me just again do the dump, because I don't know if, since it was open. So we do this. Okay, it was created. So now let's try to open it with AIDA, right? I do open. See, now I don't see that IDB. You know, there was an ID 0 here, so I don't see it. So just making sure we have the fresh latest version. Okay, so see this beauty, guys. We have now a total of 355 functions. That sounds like a myth to me. Imports. We have huge number of imports, guys, which imports with things that make sense. You know, process 32, which is to list the processes running, create directory, you know, to obviously create a file, shell execute to execute something on disk. You know what I mean? So you get functions that make sense, functions that are telling you that here is something that definitely is doing something extra than unpacking. Obviously, with the experience, eventually you will identify them faster. But then if we go to the end, we can see that we have these ones, which were the ones that the tool identified, but they didn't put it. And actually, I think that we can remove them. But anyways, and something that I really want to tell you is that we don't really care about those at this point, because we need to. We can keep analyzing, and then we will see if we need them. And another very good point, guys. Here in the debugger, we can see that we don't have labels here, but here we can see that now we have, this is a set error mode, and this is an exit process. That means, guys, that here is going to exit the program. That's another very good hint, because that means that all the logic must be before, which is here, because after that, guys, it's going to exit. So either it is going to inject into another process here or whatever, but we know for sure that now is the end of the execution by seeing this exit process. Okay, so another really quick point. Let's double click here to see guys, we have all the APIs being identified properly. I don't see any API that has question marks, you know, and that's kind of telling me quickly that even though we have those errors in the tool, actually might be just a confusion for the tool. But in the worst case scenario, guys, if we get, for example, here, and let's say that we get into an API that, let me find one. So let's say that we get this API, and here instead of this pink one, we get a question mark. We can definitely, during the debugging, identify what is the API being called, and then fix it. You know, that's not an issue, but we don't even know at this point. So, okay, guys, so that's the end of this. But as you can see, this is not about reversing the malware. Actually, we're going to reverse this malware in other labs, because it's very interesting, and it's actually very, very cool. It's very advanced. But in this lab, we're not dealing with reversing the malware. We are just dealing with deobfuscating, unpacking as soon as possible, following the carnita methodology. Okay, guys, so that's pretty much it.